So let's take a look at another question that we had question about. So this guy says solve the following ODE. I'm going to check to see if this is a Bernoulli differential equation or not. So first, rewrite this in the format that will match the Bernoulli so you can compare this. Divide by x and make sure x is not 0. What happens here? You have dy divided by dx plus 1 over x times y equals to x squared divided by x, which is x, y squared. So basically, your px is equal to 1 over x, and your f of x is x. So everything looks good and is equal to 2. So you can use u to y to power 1 minus n. In this case, u becomes y to power 1 minus 2, or 1 over y. So what happens next? Wherever you see dy over dx, you need to substitute that with the derivative of u with respect to x, right? But how? du divided by dx becomes, well, here you have negative 1 over y squared dy over dx. But what is 1 over y squared? It is equal to 1 over y squared is equal to u squared. So perfect. So dy over dx becomes negative y squared, or here in this case, you get negative 1 over u squared du dx. So let's do that. Here we have on the left hand side negative 1 over u squared du over dx plus 1 over x times y, which is 1 over u, equals to x times y squared, which is 1 over u squared. So now what? You can multiply everything by u squared, simplify this, or negative u squared, you get du divided by dx minus, let's see, u over x equals to, here you have negative x. So find the integrating factor, e to the power negative 1 over dx divided by x, which is e to power negative ln of x. Guys, you have ln, so make sure you know the domain is 0 to infinity because of ln. So basically, you have e to power ln of x to power negative 1, and ln and e, inverse of each other, so we end up with 1 over x. Multiply everything by 1 over x and try to simplify. So 1 over x du over dx minus u divided by x squared equals to negative 1. But what is it on the left-hand side that we see here? Remember that if you have fg prime, it is f prime g plus fg prime. But if you have f prime g plus fg prime, you can write it in compact form fg prime, which is basically what is happening here. 1 over x, the derivative is negative 1 over x squared. And here you have u, so the derivative of u with respect to x is just du over dx. So basically you have the derivative of d over dx of 1 over x times u, which is equal to negative 1. So if you take the integral of both sides, 1 over xu is equal to negative x plus c. So u becomes negative x squared plus cx. But what is u? U is 1 over y. So we can write it 1 over y equals to negative x squared plus cx, or y becomes 1 over negative x squared plus cx. This is the solution for this differential equation.